Often in the comments, I see points made that suggest that we are utterly alone in the universe and that there are no others in the vastness of space. This argument on its face seems valid. It must be said, a whole lot of things had to come together just so to produce life on this world, and even more to eventually produce intelligence. It stands to reason that given it was so difficult and situational here, then it must be equally or even more difficult everywhere else, and that this planet won the almost impossible lottery odds of producing what it did. This has even been suggested in scientific papers and books on two levels: the rare Earth hypothesis and the notion of the essentially impossible Earth. In the rare Earth hypothesis, Earth is a rare combination, which there are some indications that it is. We seem to live in an atypical star system as far as planets go. Mars and Venus lack appreciable magnetic fields, yet Earth has a strong one. And of course the presence of the moon and how that came to be among many others. But at the same time, the universe is no stranger to magnetic fields, so why would they be rare in Earth-sized planets is unclear. And the formation of the moon, through a glancing blow with an object early in the solar system's history, may not be that rare of an occurrence, since even with our primitive instrumentation, we've already picked up a protoplanetary collision in another star system, and are really only just beginning the search for exomoons to see what's truly common or not. But more importantly here is that the rare Earth hypothesis, as it usually is presented, assumes somewhat tightly that Earth is the only combination that can produce an intelligent civilization. That is an unknown. We may simply have not yet thought of how other paths to intelligence could present themselves, uninhabited exoplanets for evolution to go in that direction. Also in this view, but relaxing some of the constraints, life could be common, especially microbial, and every so often intelligence appears, but tends towards being very rare. This is my own sneaking suspicion about the universe, that it teems with life, but mostly simple life. But every so often across space and time, a civilization develops. The reality is then that the universe could host, across its habitable lifetime, millions of civilizations across the vastness, or more, without a single one of them ever coming into contact with each other. This could be made worse if technological civilizations tend to not last long. This situation of impossible detection and contact will forever leave this question open if we never find evidence of alien life. We may never know if we are alone. We can only on this basis assume that we aren't. This idea has been explored in science fiction, a good example being the reboot of Battlestar Galactica, where you didn't need aliens for that story, and the only thing you ever see is an alien algae planet because the question itself is irrelevant in the face of what the humans in the series face. But that brings us to the second option, that we really are alone, that at no point in the vastness of space and the trillions of years of time that will pass has what happened on this planet repeated. I'll get more into that in a bit, but this option comes with a very severe price tag on a number of levels, both scientific and existential. But we have some clues here, and they begin with the odds. On the one hand are the odds presented by the universe itself. We actually don't know what the odds are. The reason is that we only see a bubble within the universe, which could be a large one or a comparatively small one. It's the observable universe, that which the laws of physics and the speed of light allows us to see. Beyond the observable universe, we simply can't measure anything, and as a result, we can't know what's there. We can only assume that the universe is much the same everywhere, and beyond that line are more galaxies made of stars and planets, and beyond our observability, it's just more of the same. But we don't know that for sure, and never will, and it hinges on the idea of the Copernican principle, where we occupy no particularly special vantage point in the universe. This leads to a rather unorthodox solution to the Fermi paradox, the idea that there is a limit to technology, and that any species that happens to pop into existence in the universe is ultimately limited by the rules of the universe. Science fiction has often skirted or ignored this line, that aliens could achieve godlike levels of technology, that if we were ever to see it, it would be incomprehensible. But it's equally likely, at best, that the laws of physics and the universe govern highly advanced alien civilizations as much as they govern us, and thus they remain limited. The speed of light is a good example here. Often in science fiction, a trope indeed is faster than light travel. Fire up the warp drive and head off to wherever in the universe you wish to go in the blink of an eye. 1 week you can be negotiating with the Klingons, then warp over to a pleasure planet 600 light years away in 20 minutes to celebrate your diplomatic efforts. Sounds nice, but so does a coffee maker that can produce a cup of coffee with no effort or ingredients. But that's not going to happen. Someone's going to have to grow the coffee beans, roast them, and then you'll have to load them in the coffee maker along with water and brew it, and then tweak the whole thing with your choice of cream or sweeteners to make it happen, or some variation thereof. But the point is, there is no free cup of coffee. It's the same with the universe. It requires that you put certain things into achieving your goal, but all on the universe's terms. And the speed of light is a set of very serious terms because it's not simply the speed at which light propagates. It's the speed at which usable information propagates, and this governs everything. For example, time dilation. The speed of light is also the speed of time, meaning that once you hit the speed of light, time stops. It's not just a speed limit, it's a time limit, and also coincides with even more limits. This has led to many interesting questions in science, not the least of which is the question of whether a photon of light actually experiences the passage of time, and the consensus being that it really doesn't. All happens instantaneously for a photon, even though it may have traveled across nearly the entirety of the observable universe. But it too can never defeat the universe, especially if it's infinite, because of the expansion of the universe. There comes a point, and this is why we can only see part of the universe, where there is so much expanding space in the distance needed to travel to reach an end, whatever that may be, that the speed of light, time, information transfer, whatever you wish to call it, is defeated. Aliens may be no more capable of defeating this than we are, even in our state of barely understanding its rules. Again, assuming the universe works the same at all points within it. It appears to, but this rears its head again soon. But working under that assumption that the universe continues much the same further than we can see, lies a fundamental question of great relevance here. Does it extend only a little further than what we see? Or does it continue on? Possibly even infinitely. No one knows, but it dramatically changes the odds for alien life if it is indeed infinite. An infinite universe guarantees that not only is there alien life out there in the infinite vastness, but an infinite number of Earths, all almost exact copies, or not so exact, to this one. Out there would be someone identical to you, watching a video almost identical to this one, over and over with many copies. Infinite implies infinite copies of everything that is possible in the universe, including other alien civilizations, over and over with minor variations to major ones. But that brings back the question of odds. We can only work with what we can observe. But that being the case, what can we observe? Well, the truth here is that we see a whole lot of potential habitability in the observable universe. Scientists debate about habitability in star types that can do it. It's not yet known definitively whether red dwarfs, for example, can support life, but at this point, it appears they could. Add in the type K orange dwarfs and the type G yellow dwarfs like the Sun, which can certainly support life or we wouldn't be here, and all the subgroups in those categories along with the more marginal possibilities of type F, and you basically end up with well over 90% of the universe sporting habitable stars. The unlikely stars make up only a very small minority of what is. So what are the odds, in this way of framing things, that we are here? Just basing it on the number of stars estimated to exist in the observable universe, which varies depending on who you ask, in any case, we won the worst possible lottery odds that can be. So much so that they are preposterous. Lottery odds are something on order of 1 in 3.5 million on average. That's huge. You probably aren't going to win the jackpot with those odds. And sometimes no one does, and the jackpot grows. The odds are much worse for life on Earth being alone. It's not millions. or billions, but potentially sextillions. A sextillion is 1 with 21 zeros behind it. The point is, you will never ever realistically win that lottery jackpot, and there are very likely billions of Earth analogs in the universe, even if the rare Earth hypothesis is correct. Yet if we are alone, we want it. And we want it so perfectly as to allow for intelligence and a civilization to arise on this world. That does not seem very plausible, but there is another possibility. The problem when contemplating the question of whether we are alone or not has one glaring puzzle piece that is still missing. This is the question of whether abiogenesis, the emergence of life from abiotic chemistry, is difficult or relatively easy. We don't know the answer to this, but there are a few clues. Before we get into that, the bottom line is that if abiogenesis is extraordinarily unlikely and only barely just possible in this universe, then the numbers of stars present in the universe that can support life fade away as an argument. For all we currently know, the chances for the process that can produce life to happen in the universe may outweigh the number of suitable stars in the universe. And that's where our luck starts to run out. More on that in a bit. But here we have some interesting clues as to how things might work. We know that the universe teems with organic chemistry. We see organic compounds everywhere in nature that are not of biological origin. So organic chemistry is a big part of the universe and carbon is not rare. That makes up the raw materials for life, at least part of them. And there are other questions within this, such as the abundance and distribution of phosphorus in the universe that may play roles here. Again, we don't know. But the point is, organic chemistry is not unusual. We also know that the chemistry that can happen under the conditions of early Earth readily produces interesting results, and often very quickly. This involves the famous Miller-Urey experiment and its successors, where if you recreate the chemical soup that was early Earth and add in things like electricity as a catalyst, you get all sorts of compounds that life uses coming out the other side, from sugars to amino acids. And indeed, even without those experiments, evidence of naturally produced amino acids exist in some meteorite samples. So there you have the building blocks of life occurring in nature as a product of just chemistry. That can lead to life, and while we don't know what the rules of life actually arising are, we know some of the rules for the building blocks, and they are relatively straightforward under the right conditions. But that's not getting into things like RNA and DNA. Those are a step much further into the territory of complexity amid a lack of clarity. We also know that life arose around this world at the very first possible moment it could. This is even pushed into the late heavy bombardment as of late, and it's hard to see how life could have arisen in that environment on Earth. This leads to three possibilities. One is that it was all luck amid impossible lottery odds. Here, it's just some tidal pool where chemistry is occurring, all while the rest of the planet is getting disrupted by comet impacts. Unlikely upon unlikely for that one. The second is that abiogenesis is easy and robust, and thus it happens throughout the universe within a wide range of conditions. The third is that life did not originate here, rather it was deposited here from another impacted world that was better off than Earth was. Mars fits that bill. At the time life arose on Earth, from what we know, Mars appears to have been a better planet for abiogenesis. Now again, we don't have a complete picture of this, but at this point in time and our understanding, Mars may well have been the cradle of life in those days, and deposited itself through impacts to other bodies in the solar system through panspermia. We simply do not yet know the answer to this question. But the argument can be made that if life did arise on early Earth and wasn't transplanted here, then the conditions of early Earth appear to have been far from ideal. Yet here we are with our cell phones and our civilization. Another issue here is that our sun may not be ideal for life. There have been suggestions that Type K orange dwarfs may offer more stability and longevity for life and intelligence to occur, rather than our short-lived star. Yet at the same time, the circumstances of the solar system itself come into the equation, such as the presence of our moon and its tidal effects favoring life, the presence of Jupiter to clear out the inner solar system of debris, the activities of plate tectonics and the carbon cycle, and any number of factors that played into our presence on this world. Yet again, all of this makes the assumption that our natural history is the only path to intelligence in the universe. We certainly do not know the answer to that, and there may be other ways. And it's no secret that nature surprises. And here is where it gets spooky. So after centuries of future investigation, we find no evidence of other life or civilizations in the universe. Then what are the implications of that? Say thousands of years. Say we go an equally long period where the actual chemistry of abiogenesis remains a mystery, or say the odds of it end up being nearly impossible, worse than the sextillion odds. What if everything eventually points to the notion that we could very well be alone? What if we could reasonably, maybe definitively, say there is no such thing as alien life? Well, it boils down to the apparent fact that you live on an impossible planet. Earth is no longer just one exoplanet amongst untold numbers of similar worlds. Remember, planets may well outnumber stars in the universe, raising the odds even more. Rather, it becomes something like the island from the series Lost, where things happen here that do not happen anywhere else in the entirety of our vast observable universe, and perhaps the even more vast inobservable universe. Assuming, again, it's not infinite. Here, magical organic chemistry occurs, and while science and indeed the universe likes repeatability and verification, here is something that cannot be repeated and cannot be independently verified. And that it eventually, across billions of years, led to intelligence and a civilization, us. And that raises the odds further still. Our own existence, therefore, becomes impossible in a practical sense. Yet here we are. What might that imply? But it gets even worse. This involves the so-called fine-tuning problem. Popularly, this problem in a nutshell highlights that our universe seems to be fine-tuned for life to occur, but that's actually a rather superficial viewpoint of this matter. It's not simply fine-tuned just to allow for life to exist. The problem is greater than that. It's fine-tuned twice. The first is for matter itself to exist. Had a number of parameters been slightly different, then inanimate objects couldn't exist in this universe, right down to the atom. It is fine-tuned for matter and the laws that govern it to exist, so much so it can lead to life and intelligence. But just the existence of matter itself is where it starts. And that's where the second fine-tuning happened. Had the universe not had minute temperature differences evident in the cosmic microwave background radiation, then matter couldn't have clumped to form stars. Atoms might exist, but it would have been an isotropic universe where atoms all stayed the same distance from each other, and nothing would have ever formed. More, it's still an open question as to why there appears to have been slightly more matter as opposed to antimatter for any matter to be left in the universe at all. Again, many lotteries were won far before we get to the question of life and the impossible Earth. Here, it could be said that it's an impossible universe question, and that brings us to the idea of a multiverse. One of the attractive features of the idea of a multiverse is that it solves all of these problems, at least in a mathematical sense. If this universe is one of many, perhaps infinite universes, then it's quite acceptable for it to have simply gotten lucky to have these conditions, whereas most universes do not. That makes things easier to understand, but there isn't the slightest shred of evidence for this. For all we know, this is the only universe. And since all we think we can observe is a part of this one universe, and not measure anything outside of it, then we face odds so high that they cannot even be calculated because you could never know enough to do so. It's so high, you can't assign a number. It's all guesses without much to go on. So there we would be, an impossible intelligent species on an impossible planet in an impossible universe. It's at this point that we have to start rethinking science. In astronomy, as I mentioned, a fundamental principle is the Copernican principle. This is the idea that we occupy no special point in the universe, and that everywhere we look, we see more or less the same thing, or at least we see consistency. In the impossible Earth scenario, this gets turned on its head, and it becomes a Copernican assumption rather than a principle. You have to assume everything, from a truly unique, privileged vantage point. Here you occupy the most important point in the universe, and perhaps the multiverse if it exists. Our magical island, suspended in space, is the one place where consciousness and the ability for the universe to perceive itself exists, and there is no other. How could you then say we occupy no special position in the universe when we very clearly would? We could never then assume that our observations of the universe were truly universal, given our privileged vantage point, and we'd have to make the leap that what we see is universal and real. And that's where simulation theory starts looking a lot more plausible. Like the multiverse idea, if it's simply a simulation of some sort, then none of these problems matter. It's the way it is because it was supposed to be that way. But perhaps the reality of all of this, a glaring one maybe, is that the simplest explanation is that we are not alone. Perhaps the universe teems with life, some of which goes on to become intelligent, and we are just one example of many, whether common or rare, spread through space and time across a multiverse, where this universe just happens to be such to allow for life, consciousness, and intelligence, to the point of beginning to understand itself, even if the vast majority of the universe is hostile to life. So anyway, food for thought. But whenever one sits down and does thought experiments on how we might be alone, it pays to remember the costs that come with that and the sheer implausibility of it. Number one, you can't ever prove it in the observable universe bubble. There will always be unknowns in our situation. And number two, the likelihood of us living on a magical lost island where unrepeatable things happen is quite a bit worse of a proposition than we live in a universe full of alien life. But if we are alone, and that is the reality of things, then our universe may be far stranger than anyone could have imagined. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently finishing up my daily existential crisis. I'm actually used to them at this point, and when I wake up in the morning, well, I'm a YouTuber, so afternoon really, I ask myself excitedly what dread awaits me in my daily research and coffee contemplation, and then I gleefully go make videos and write novels about it. Very questionable. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.